STAAR Science Tutorial 55, TEAC 8.11d, Human Dependence on Ocean Systems. TEAC 8.11d, recognize human dependence on ocean systems and explain how human activities such as runoff, artificial reefs, or use of resources have modified these systems. Human dependence on ocean systems. Humans have relied on the Earth's oceans as a primary food source for thousands of years. In many human communities, fish and shellfish are the primary source of food. The Earth's oceans contain salt water, which cannot be used directly by humans for drinking and watering crops. But the Earth's oceans do indirectly provide all land life with fresh water through the water cycle. Most of the evaporation in the water cycle occurs from the Earth's oceans. This water vapor, now free from salt, condenses into clouds. The wind blows some of these clouds over land, where the water falls back to land as precipitation. Some of that precipitation sinks into the ground to recharge underground aquifers. The precipitation that does not sink into the ground eventually returns to the ocean as runoff in streams, lakes, and rivers. River runoff from the water cycle can be used by humans for crop irrigation and drinking water. All non-ocean life relies on freshwater runoff for their survival. Ships crossing the Earth's oceans provide an efficient means of transportation of trade goods between the continents. A stable sea level is essential to maintaining ocean ports. Many of the Earth's largest cities are built on ocean coasts very close to present sea level. The Earth's oceans are used for recreation such as boating, diving, surfing, and sport fishing. Oceans store a large amount of heat, helping to stabilize the Earth's climate. Ocean currents such as the Gulf Stream move heat from the tropics to Arctic areas, changing regional climates by moderating temperature extremes and increasing rainfall. Oceans absorb a large part of the carbon dioxide created by humans when they burn fossil fuels. This helps slow human-induced global warming or climate change. This diagram shows the carbon cycle in billions of tons of carbon per year. Phytoplankton, microscopic floating plants, in the Earth's oceans create a large part of the oxygen that sustains animal life on Earth. Overfishing. Only certain parts of the ocean, usually where cold water is rising from deep currents, have a large population of fish suitable for human harvesting. Such an area is called a fishery. Sustainable use of a living resource such as fish, shrimp, crabs, or clams occurs when the resource species can reproduce fast enough to maintain a stable population by replacing those caught for food. In many countries, including the United States, laws have been passed to limit fish catches to a sustainable quota or maximum amount to allow fish populations to grow back to healthy levels. During the last 100 years, the Earth's human population has increased from less than 2 billion to over 7 billion. To fill humans' food needs, seafood catches have increased beyond sustainable use. Populations of many fish and shellfish species are dropping quickly because of overfishing, removing fish faster than they can reproduce. Even with these quotas, it will be many years before U.S. fish populations return to healthy levels. Most of the Earth's oceans are in international waters not governed by any one country's laws. Even when international treaties limiting overfishing have been passed, many countries or individuals have refused to obey these limits. Enforcement of these laws and treaties is difficult. As a result, the population of many of the Earth's fish species is still dropping. As the Earth's supply of fish shrinks and demand for food increases with human population, the market cost of the remaining fish increases, making it more likely that humans will continue to overfish until fish populations are wiped out. Runoff and pollution. Toxic chemicals from factories and cities wash into rivers and collect in the Earth's oceans. Various toxins in runoff water collect in fish, either killing them directly or making them poisonous for humans. The burning of coal in factories and electric power plants releases mercury into the air. Precipitation cleans the mercury from the air and deposits it into the oceans. Mercury collects in fish and is carried up the food chain into large predator fish such as tuna. Mercury is highly poisonous to all animals and can cause genetic and developmental defects in humans. Farmers often use fertilizers, pesticides, and herbicides to increase crop yields. Rain washes some of those chemicals into rivers where they are eventually carried to the ocean. High levels of fertilizer in rivers can cause algae blooms. When the fertilizer is used up, the algae dies and begins to decay. The decomposing bacteria then use up all the oxygen in the water, causing a fish kill. Each year, a large area of the Gulf of Mexico becomes a dead zone because of fertilizer runoff into the Mississippi River from American farms. Shown to the right is a fish kill caused by oxygen depletion in the Gulf of Mexico. The map below is of the Gulf of Mexico dead zone. Habitat destruction and creation. Wetlands, estuaries, and protected bays along ocean coasts are important breeding grounds for fish and shellfish. Many of these essential habitats have been destroyed by human development and pollution. This habitat destruction will make it even harder for fish populations to recover. Humans have begun to help fish populations recover by creating artificial reefs. A natural coral reef supports large fish populations by giving a habitat for the producers upon which a food web is built. When humans sink old ships, oil rigs, train cars, or other poison-free structures in shallow water, new food webs, much like a natural coral reef, can develop. Concrete blocks, tires, or a sunken ship can all act as artificial reefs. Ocean currents and floating garbage. Most of the Earth's oceans have circular currents that create a whirlpool-like vortex at their center where floating garbage collects. Both the Pacific and Atlantic Oceans have vast areas filled with floating garbage, including foam and plastics that will take many centuries to break down. This garbage is sometimes eaten by fish, turtles, and seabirds, causing their premature death. Because most of these floating garbage dumps are in international waters, no one country is responsible for cleaning it up. It is likely that these floating garbage dumps will continue to fill in the future. The map below shows the main oceanic vortices in which garbage collects. Climate change and rising sea levels. Scientists believe that the Earth's climate is warming due in part to human burning of fossil fuels and the resulting collection of carbon dioxide in the air. Carbon dioxide is a greenhouse gas that helps trap heat in the Earth's atmosphere. The warming planet is causing an increase in glacial melting, adding additional water to the Earth's oceans. Floating ice is also melting, causing the darker, open Arctic Ocean to absorb more heat from sunlight. The warming water is also expanding since warm water is less dense and takes up more volume than cold water. Scientists predict that the Earth's sea levels will continue to rise over the coming centuries. Future sea level rise could create a massive displacement of human populations from coastal cities and low-lying areas and result in the complete destruction of island countries. Rising sea levels could also destroy wetlands that serve as the nurseries for fish populations. Warming oceans may fuel stronger or more frequent hurricanes, causing additional damage to coastal cities. As more carbon dioxide becomes dissolved in ocean water, the acidity of the water increases, making it harder for coral and shell-creating organisms to survive. Much of the producer base of the ocean food chain depends on shell-creating organisms. The entire ocean food web could be seriously damaged if oceans become too acidic. Coral reefs depend on a narrow range of temperatures to survive. As ocean temperatures rise, coral reefs may die, further reducing the fish populations that coral reefs support.